This is example 3. We're given a formula of a function p of t. It's exponential. It's decreasing because we see that the factor 0.924 is between 0 and 1. And when your factor is between 0 and 1, you know your exponential function's decreasing. We've also been given the graph of that exponential function, and we also see there that it is a decreasing function. We're told in this problem that t represents the number of years after 1950, and we're told that p of t is the population of a town in thousands. So I've already completed here part A, where I labeled the meaning, the real world meaning of each axis. The horizontal axis is the number of years after 1950, that's the t. The vertical axis is the population in thousands, p of t. And so part B asks if the function is increasing or decreasing. It's definitely decreasing. As we travel left to right, the function does go down. So what's the practical real world meaning of this? We're saying as we travel from left to right, meaning as the years increase after 1950, then the function height goes down, meaning the population in the town goes down. Part C then asks us if the function is concave up or concave down. Our function is decreasing, but you see that it looks like a right side up bowl, so it's concave up while decreasing. So what's the practical real world meaning of this? What you want to think about here is the change in that slope that's occurring. Over on the left side, it's decreasing at a very steep rate, meaning it's decreasing very fast rate during that first year. And then later, in later years, it's decreasing still, but you see that it's a very shallow rate of decrease. So in later years, it's decreasing at a slow rate per year. So overall, as the years go on, the population is decreasing, but at a slower and slower rate each year. So as the years goes on, the number of people in the town decreases, but it decreases a smaller and smaller amount each year. There's a fast rate of decrease per year at first, and as each year goes by, there's a smaller and smaller amount of decrease each year. Then asks us for the right tail behavior. So we know that it's decreasing concave up, but on the right tail, what we see is that we have this exponential function behavior where the exponential function gets closer and closer to the x-axis on the right tail. That means as the t values, the input values get higher and higher, the output values, the p of t values, get closer and closer to 0. In limit notation, we say the limit as t diverges up to infinity, the limit of that function p of t is 0. It's getting closer and closer to 0. In real-world terms, to say that t is diverging to infinity means as the years get higher and higher, we're saying the p of t function approaches 0. That means the population of the town gets closer and closer to 0 people in town.